Hello, sir.
Yeah, hi. Yes.
Hi, sir.
Can you hear me?
Yes, sir. I can hear you.
Okay, fine. Yeah. You
So
can see
5 more
this.
minutes. Yes, sir.
You can
Yes, I
see.
can see you. Yeah, yes, sir. I can see.
Okay, fine. Thank you.
Good evening, all dear participants. Welcome you all for the 2 weeks International FTP on Data Science Tools. I welcome Mr. Shankara Velu, sir. Thank you, sir, for accepting our invitation. I welcome you, sir. Hemambika, start the session.
Very good evening to one and all present here. We, the Department of Artificial Intelligence and Data Science of Ishwari Engineering College, are hereby delighted to welcome you to the 13th day of our International Faculty Development Program on Data Science Tools. Today's session is on PyTorch. I'm extremely delighted to introduce the keynote speaker of this session, Mr. Shankar Velu. Mr. Shankar is an enterprise architect with 12 plus years of experience in the software industry field, responsible for proposing high-level solutions and helps to drive the improvements for data and application architecture. He is currently engaged with AquaConnect, a leading full-stack aquatech company. His expertise is in application development, mobile app development, Zoho services, data engineering, data science, data visualization, GIS solutions, NLP, and cloud services. We are really honored to have you on this platform, sir. This session is yours.
Yeah. Thank you. Thank you, Hemambika. So, this is Shankar. So, I am working as an enterprise architect at AquaConnect. I like to explore new technologies. I worked on data science, data visualization, GA solutions, mobile and app development, web development, and cloud services. Connect me at LinkedIn. Today we are going to talk about PyTorch. This is the agenda we are going to cover today. So what is PyTorch? Why should learn this framework? And fundamentals of PyTorch, PyTorch applications, our real-time examples in AquaConnect. So here I am going to explain how as an AquaConnect solve our problem using PyTorch. If you have any questions, just post it on Q&A chat box window. We will see in on Q&A session. What is PyTorch? PyTorch is a machine learning framework based on Torch library. It is used to create deep learning models. It is developed by Meta AI, formerly known as Facebook. It is maintained by Linux Foundation. It uses GPU, graphical processing unit, to handle large setup data. It is open source, used by major companies such as Tesla, Microsoft, OpenAI. 58% of market share is PyTorch is having now, but still it's growing. Next, why should learn this framework? It can handle lots of set of data sets and it will load data parallelly. So if you have a large set of data sets giving into your model, that model will split into smaller chunks and that will load your data parallelly. That's how that will manage, PyTorch will manage your memory. Because data handling libraries such as data loaders, it is easy to learn. If you know Python, then you can easily learn this framework because this is the Python framework. What are the debugging tools you are using in Python? You can use it in here also. And it has strong community support and well documented. workflow. If you have a data, then you can feed the data into PyTorch model that will give you the base model, and you can use it that base model into live data. We have 7 key features in PyTorch: loss functions, GPU, graphical processing unit, CUDA, it's a software, seamlessly work with hardware, and tensors, it's a NumPy array, NN module, it's a neural network model, data loaders, it will load large set of data easily, and data sets, it has
Sorry, sir.
pre-built.
Sir, sir, can you little bit zoom your slide?
Okay.
The participants can't able to see your slides. That is. Yes, sir. Fine, sir. Thank you.
Is this fine?
Yeah.
That's fine?
Yes, sir. Yes, sir. Now it's.
Okay, fine. Thank you. So I will explain one by one in upcoming slides. Tensors. It's a NumPy array. It's an n-dimensional array. So only tensor is just single x-axis. Only one axis is there. So 2D tensor is x and y axis. 3D tensor is x, y, z axis. If you see the 4D tensor, it has only one axis. Within that axis, you have a block. So each and every block has 3 axes, x and y, x, y, z axis. That's why it is called 4D tensor. Same way, you can make it n-dimensional array. Whatever you are giving input to that model, PyTorch model, that is converted into n-dimensional array. It is called a tensor. Whatever you are getting from that model is also, it's a tensor. After that, the tensor is converted into human readable format. So neural network model. All the models in PyTorch is inherited from this model only. So if you see the right side image, so can anyone say how many tensor is there? Is that 1 or 2 or 3D, 4D? Okay, I will slow down my voice. It's a 4D tensor. So you have a x and y axis, and each and every image has x and y axis. So it is called a 4D tensor. Here we are grouping. So wherever you are, okay, fine, sure. Here the neural network is doing grouping your data. Something like that aeroplane is grouped into one category and automobiles is grouped into one category. This is how our brain also working. So whenever you are seeing new thing, so it is compared to previous data. That will group whatever you are seeing. Oh, it's not audible. Can you hear me? It's audible?
Yes, sir. It is audible.
Okay, fine. Next, data sets. Here in the image we have 7 different type of flowers. This flowers is feed into PyTorch model. So if suppose 8th flower is coming, then that PyTorch model will predict this is the flower. And PyTorch has built-in preloaded sample data sets. You can use it to train your model. Next, data loaders. If you have large data sets, then it will split it into small chunks or small patches. Then it will load all that data parallelly to your memory. If you see that image, you have a n number of data. The n number of data is segregated or grouped into chunks, and then it will load to that memory. Loss function is nothing but you have a target value and predicted value. So difference between the predicted value and the target value is called loss functions. You have an image, for example, you have an image, you wanted to convert low resolution image to higher resolution image. There is a possibility to have a data loss. If you are converting low resolution image to higher resolution image, then it have possibility to data losses, something like pixel losses is there. So that is called a loss function. Choosing GPU. GPU is a graphical processing unit. If you have a small amount of non-complex data, then PyTorch will suggest you to use CPU. CPU means central processing unit. If you have a large size of data sets and complex data sets, then PyTorch will switch to GPU, graphical processing unit. It will split your data into chunks and it will load parallelly on the asynchronous way. CUDA. CUDA is a software and it seamlessly works with hardware. It is developed by NVIDIA, NVIDIA. It will do intensive operations. PyTorch applications. So we have a computer vision, NLP and reinforcement learning. So different type of category algorithm is there used to develop our model. Computer vision is used to image classification and object detection. This computer vision we are using in our use cases to extract data from image. NLP, natural language processing. We are using this algorithm to translate our data and chatbot. Reinforcement learning, it is used for robotics for automation, self-driving cars, and we are using this reinforcement learning to predict our pawn boundary. real-time use cases in Aqua Connect. Before going to this, so I need to clarify one thing. What is aquaculture? So what is aquaculture? Can anyone say? Okay. Aquaculture is cultivating shrimp in a controlled condition, controlled environment. India is the second largest exporter on that field. What AquaConnect is doing here, we are helping farmers to get more growth on their seeds, shrimp. And we are doing B2B sales and much more on this field. Now we are come to AquaConnect use cases. We have an app, Runners app. Each and every day, AO visiting, AO means aqua officers visiting farmers. While visiting farmers, they are taking pictures. With that picture, they are tagging some information, something like DOC, base of culture, what farmer name, what farm name, which pond, which location that pond is located. This information tagged with that image and sent back to us. We are using PyTorch OCR model, optical character recognition model, to extract those data from that image, and we are use it for analysis purposes. Second one is farmer credit program. We are giving credit to farmers, and we are doing B2B sales. Disease and species prediction. If you see these use cases, you have a data. In AquaConnect Farmer app, you are collecting data, and giving credit, you are getting data, and input sales, you are getting sales data from the sales team, and we are doing image species prediction, object prediction to get some data. So how you relate these data into that pond or farmer? Which farmer is performing well and which pond is performing well? How you find out? That is the problem we are going to solve here. We are downloading these images from satellite. It's a low resolution image, and we used PyTorch model to convert this low resolution image to higher resolution image. Here is the loss function comes into picture. If you see left side image, it's not clear, but it is accurate. If you see the right side image, it is clear, but some pixels is pixelated. This is what loss function. So we got a high resolution image. We gave these images to the ground team to mark that boundaries. If you see the corner of the pond, so they are doing marking manually. Each and every location we created 200 images to mark that pond. Left side image is the actual image. This is the high resolution image we are getting from ground team, and center one is the marked image. So ground team is marked image is here, and right side image is the predicted image by model. Now you can see that model is predicted accurately. And if we see here, that center image, some of the ponds is not marked. But if you see the right side image, model predicted image, that model is predicted properly. This is around 70 to 80% accuracy. Right now we are getting. So each and every region we created 200 image. Around 2000 image we created for a single district. More than 2000 images we can see. So we feed those images into model and we got this output. Each and every image has around 140 to 150 MB. So if you want to load all the images at a single time, that CPU will split those images into chunks and it will load those images parallelly to the memory. So it is handled by PyTorch model. So that's how the GPU comes into picture here. And next challenge is, you know the bond boundary and you have to segregate which is shrimp pond and which one is fish pond. How you differentiate that? That is our next challenge is here. So one is, you can say, size of the pond, and second characteristics are aerator. Third characteristics is center field line, and fourth one is farming period. These are the characteristics we found from the field officers. I will explain you one by one. Okay. So first of all, we need to segregate size of the pond. If you see blue color mark, that is shrimp pond, and that yellow color, orange color mark is a fish pond. So the shrimp pond size is less than 2 hectare, nearly 1.5 hectare, and more than 2 hectare, you can assume that is a fish pond. And aerators. So aerators is used to mix the air into your water body, because shrimp will stay in bottom of the water, so he not come top of the water. So that's why we need to have aerator to match that oxygen content in your water. But fish is not like that. Fish will come top of the pond and it will manage. And center field line. If you see the left side image, you can see slight light line is there. That is the line used to feed the fish. But shrimp they are splitting that feed over the pond, every area. So if you found center feed line, then it is a fish pond. So if you see the right side image, then you can I marked as a yellow color box. That is the center feed line. My voice is still low. Okay. So this is how we can differentiate. And one more thing, one more characteristics is there is forming periods. So shrimp pond has forming period is 120 days to 150 days, and fish pond has forming period is more than 5 months. So less than 3 to 4 months it's a shrimp pond, and more than 5 months is a fish pond. One more special characteristics is that so a single pond has aerator and center field line, and the size of the pond also is high. That is called polyculture. They were doing both the species. They are cultivating fish and shrimp in a single pond. That is called polyculture. That is a special case. Not everyone is doing, but we can say we are right now focusing on fish only. So fish is the most wanted species in India, and we are exporting shrimp. So right now, we concluded the data. So whatever you are collecting, you can say what is the pond, where that pond is located, and what type of pond is that? It is a shrimp or fish pond. So now this data is given into our field officers. They will manually mark each and every pond to that particular farmer. So they are going into field while visiting that farmer. They are collecting how many ponds are there. So which location is in that pond, and what are the ponds is performing well, and what is the pond size, and what is the farm, and each and every details they are collecting from field farmers. Now if you see, this is the output we are getting from field officers. So this is the pond, and if you click the pond, you will see that pond details, farmer, farm information, everything. So what is the species name, that what culture is doing that farmer. So each and every details we are collecting from field officers. Thank you. Yeah. Do you have any questions? Okay, so coding. if we got a chance for next time, I will explain you. Okay, so I can give whole coding of what we written. So maybe I can explain each and every part. So each and every type of things we are doing. Okay. If you know more into, if you know more on that information, so what we are doing, just ask me, then I will explain. Okay. One example. Okay. So okay, we can we can take this one. Okay, satellite image. So we are downloading this satellite image from Sentinel-2 satellite. While you are downloading that, they are giving a low resolution image. If you are feeding these images to your model, then that image is itself is not clear. So that will not predict everything. So that's why we used PyTorch Enhance library. So that algorithm is used to convert that low resolution image to higher resolution image. So that's the algorithm we used to convert this image. Is this fine? Okay, so for this model, we used UNet model. So whatever you are predicting here on that ground team data and the model predicted data, right? So here we are using UNet algorithm to used to predict on boundary. That is the model name. And Amit Kumar, you can use Google Earth Engine. So they will give 1 month old data to download satellite images, or else you can use Sentinel-2. So that will give 5 days old image. So whichever you want, you can download it. NumPy is a multi-dimensional array. So PyTorch is a framework, deep learning framework. And you can say PyTorch has NumPy array built in. Yeah, of course, you can use deep learning model. Any questions? Why?
I hope there are no more questions anymore. So can we end this session?
Yes. Oh,
Thank you so much, sir, for this informative session on PyTorch. Participants, please make sure to fill the feedback form that is sent in your groups, and the link is also attached to the chat box. And tomorrow is the last session. It is on 9 by Naveen Kumar. And I'd like to conclude this session with a word of thanks. We are delighted to have you, sir, Mr. Shankar Velu, sir, with us today. And thank you very much for this informative session. We'd also like to convey our thankfulness for accepting our invitation and providing support on knowledge and PyTorch. We thank you very much, sir, for taking time out of your busy schedule and joining us. I'd also like to thank all of our participants for taking advantages of this session. Thank you all. Hope you learned a lot. Have a wonderful evening.
thank you.
Thank you, sir.
Yeah, thank you. Thank you so much.